Afiq and I will present to you about the intro. One actual soil investigation was held is to determine the nature of materials, profile and properties of the subsurface material within the depth of influence of the ground. And this soil investigation work was located at Residential Development in Jalan Semerah Padi, Mukim Ceras, Wilayah Persekutuan Kuala Lumpur. And standard penetration test was held and there are two samples were carried out from the SPT test, which is undisturbed and disturbed sample. And from the undisturbed sample data, one-dimensional consolidation test have been carried out. And all the parameters of one-dimensional consolidation test are modeled in Plaxis 2D software using three different models, which is more column model, hardening soil model, and soft soil creep model.
Alright, I will continue to the chapter 2, which is the literature review. In the literature review, we have divided to the 4 parts, which is one-dimensional consolidation test, more column models, hardening soil models, and soft soil creep model. We go to the first one, which is the one-dimensional consolidation test. The overburden pressure due to fill must be neglected in order to obtain the true over-consolidation ratio. It was also found at the collaboration by Terzaghi and Peck in 1967. In this study, the result from the one-dimensional consolidation test from the laboratory test have been used for the three models in Plaxis 2D, which is the model are more column models, hardening soil models, and soft soil creep models. We go to the first one, which is the more column model. The more column models of plasticity is most commonly used by design engineer and scientists to simulate sand behavior in geotechnical engineering challenges. And for the hardening soil models, which is the hardening soil models is one of the few soil models in Plaxis 2D. It is a second order hyperbolic isotropic elastoplastic modeling models. In hardening soil model, extra additional parameter was added. It gives more precise and accurate result, which is the parameter is added, which is the triaxial loading stiffness, odometer loading stiffness, triaxial loading stiffness. And the last one is soft soil creep model. The soft soil creep model has a higher water content, low strength, a low coefficient of permeability, and a noticeable theoretical features in terms of engineering properties. For the three types of model, which is the soft soil creep model, hardening soil model, and more column model are used to complete this study, which is we insert to the Plaxis 2D software.
For the model that is proposed, the model for the 1D consolidation test was based on this figure. The load will be applied at the top of the soil column. The groundwater boundaries were set to be closed at the bottom and the sides of the model to simulate the impermeable boundaries of the test. The top boundary is set to open. This will ensure that the half-closed layer drainage will be simulated. The soil will be set as linear elastic and the drainage of the model is undrained A. The Poisson's ratio is 0 to prevent any transverse strain. The parameters for the soil model, we have three types of material model that was used in the simulation. The first is more column, second is hardening soil, and the third is soft soil creep model. So this table shows the soil parameters for the more column model. This table shows the soil parameter for the hardening soil model. And the final table shows the soil parameter for the soft soil creep model.
The procedure for modeling 1D consolidation testing in Plaxis 2D will be explained by me. Firstly, in the project properties, axis symmetry model is set and the contour is filled according to the model proposed. Then, in soil interface, for modified soil layer, we set height as 0 since there is no groundwater table for the model proposed. Then, for the soil properties, the general and parameters are followed as each type of soil testing model proposed. For example, these are the examples for the general properties for more column model. Then we move to the structure interface, which is line load of 1 kN per meter is selected and activated. After that, general mesh shall be done in the mesh interface. Then, inflow condition boundary conditions are set to close at the bottom and the sides of the soil model geometry. And then we proceed to stage construction. Initial phase is set to default. Initial stresses are generated in the initial phase by using K-knot procedure for the calculation type. Then we add phase 1. Calculation type is set to consolidation. Time interval is set to 0.1 days. Continue to add phase 2 to phase 10. Time interval of 0.1, 0.3, 0.5, 1.0, 3.0, 5.0, 10.0, 30.0 and 50.0 days are set respectively. Later, proceed to calculate to view the result of the settlement that will be generated after the calculation is done. In this interface, the settlement from the initial phase 1 to phase 10 is obtained. The procedure from setting of soil properties till obtain result of settlement will be repeated for the other soil testing models, which are hardening soil model and soft soil crete model.
Table showed the comparison between three constitutive models. All three models have zero settlement at the initial phase. This is because there is no settlement at the early stage of the consolidation. After the initial phase, more column model showed the settlement increasing to 0.1484 meter at phase 5. Then the settlement remained constant until complete phases. Meanwhile, hardening soil model increasing to 0.01753 at phase 3 and remained constant. Soil creep also showed settlement from the initial phase to the 10th phase, but the settlement are very small. The settlement is 0.001401 at phase 1 and continue to increase until phase 10 with 0.0103 meter. Based on the results obtained for 1D consolidation test, it can be concluded that from these three soil models, soil creep model is the most effective and suitable to determine the settlement behavior of the soil in the study. Soil creep model has lower soil settlement compared to more column and hardening soil model. Other than that, soil creep model continues to settle until phase 10. This showed that this model also suitable for long-term settlement. Soil settlement is critical and must properly predicted to avoid future problems.
Now, I continue to the conclusion of the study. Based on the result that obtained, it can be concluded that the highest soil settlement is more column model compared to hardening soil and soft soil creep model, while the hardening soil model has the higher soil settlement compared to soft soil creep model. As the soil settlement of the soft soil creep model has the lower settlement, this model is the most efficient and most suitable for the long-term settlement compared to other models. That's all for me.